Good day guys, I am Jay Omido.
And I'm Aneya Samson.
And we're here to talk about the different types of discontinuity and give some illustrations for you to identify one discontinuity from the other.
We hope that by the end of this video, you'll be able to characterize the different types of discontinuity and be able to demonstrate a clear understanding of the topic.
Without further ado, let's start.
So first of all, we need to know the types of discontinuity. We'll be discussing the three types, namely whole or removable discontinuity, jump essential discontinuity, and infinite essential discontinuity.
But before that, we have to define three conditions needed for a function to be considered continuous. These conditions are important in determining the type of discontinuity on a given interval.
For the first condition, f of c must exist. We can find out by substituting the constant to the given function. If the result does not exist, then the first condition is not met or satisfied.
Now, for the second one, the limit of function x as x approaches c must exist. You can solve this by evaluating the limit of the given function. For additional help, please refer to the other videos in this channel. If the limit of the function does not exist, then the second condition is not met.
And now for the last condition, f of c must be equal to the limit of f of x as x approaches c. If not, then the third condition is not met. Now that we discussed the three conditions, we can now move on to the different types of discontinuity.
Right. So first, we have the removable or whole discontinuity. It is characterized by the fact that the limit exists and can be fixed by redefining the function. Let's have an example. First, we have to find the value of f of c and if it exists. To do this, we simply need to substitute 1 to the corresponding function, which is f of x is equal to 5. So the result is 5, meaning that f of c exists. To find the value of the limit of f of x as x approaches c, which is negative 7. We can say here, the limit of f of x as x approaches 1 is equal to negative 7. But f of 1 in the way that it had been graphed is equal to 5. As you can see, there is a hole present in the graph, hence the name whole discontinuity. This can easily be redefined by letting f of 1 be equal to negative 5. Now, both f of c and the limit of f of x as x approaches c exist. The only problem is that these two statements are not equal, so we can say that the removable or whole discontinuity only satisfies the first two conditions.
Now that we're done with the first type of discontinuity, it's time to move on to the essential discontinuity, which includes jump essential discontinuity and infinite essential discontinuity. The jump essential discontinuity occurs where the function approaches two different values from either side of the discontinuity. To further explain, let's have an example. In finding out if f is discontinuous at x, same steps are conducted. We have to identify which statements the given function satisfies. In this example, we can see that f of c is equal to 5, therefore it exists. However, the limit of f of x as x approaches c does not exist because the left and right sides approach different values as x approaches 3. That would mean that the third condition is not satisfied. In a jump essential discontinuity, only one of either condition, 1 or 2, is satisfied and the third condition is not met.
Finally, we have the infinite essential discontinuity. An infinite essential discontinuity has a function approaching an infinite value which does not exist. Let's have a graph of this discontinuity. Let's say we have an asymptote at x equals 1. And when we try to trace the graph from the left, you'll see that it is unbounded. The same goes for the right side of the asymptote. So that will result to the equation of the limit of f of x as x approaches 1 from the left being negative infinity, and the limit of f of x as x approaches 1 from the right being positive infinity. As you can see, all three of the conditions are not satisfied in an infinite essential discontinuity.
Sum it all up, a removable or whole discontinuity satisfies only the first and second conditions. In a jump essential discontinuity, only one of either condition 1 or 2 is met, and the third condition is not satisfied. Lastly, an infinite essential discontinuity does not meet any of the 3 conditions. Just remember the 3 conditions and you shouldn't have a problem in identifying the different types of discontinuity.
Now it's time to test if you learned the necessary information about this lesson.
To test your own knowledge, we'll give you 5 examples of different discontinuities to identify. Let's start! Time's up! We hope you answered them all correctly. If not, it's okay. Just learn from your mistakes and you'll be acing every test.
So that ends our short video tutorial about the different types of discontinuity. We hope that you've learned from this video as much as we did.
If you liked our video, please give us a thumbs up and don't forget to subscribe to our channel and view the other videos on other basic calculus topics. Also, feel free to leave your comments and suggestions down below.
Thank you for watching, guys.